Let's start with basics. What does shell mean? Shell. Have you ever been to like some tropical paradise, Bahamas or Caribbean, somewhere? Coconut shell. What does shell mean? Go ahead, Anna.
Like hollow.
Something that is hollow, right? Coconut shell is an easier way to visualize. Okay, something that is hollow. Cylindrical shell, it simply means a hollow cylinder, right? And you might wonder, well, how am I going to make use of a hollow cylinder to come up with a volume? Reasonable question. Yes, no, maybe. I'm very hollow. Gotcha. Wake up, people. You might wonder, well, how could hollow shells result in a volume? Any thoughts? No? Come again? Okay, good. Louder, Alex.
What they can hold within.
A hole within?
What they can withhold within.
Oh, what they can withhold. Okay. So, do we agree that this is a cylinder? Yes. Not solid, but hollow. Right? Okay. Right, really hard. Okay, better. Another cylinder, hollow. Good. What happened? Would you say that things became thicker or thinner? Isn't it?
Thicker.
Thicker. So another hollow shell. Okay. Don't want to get too dramatic here, but you get the point, right? I'm trying. So we'll do one more. Another cylinder, hollow, but thin. I don't think it's going to go in, but we'll try. Okay, look, can you pull this? I don't ask for help. It's not in my nature. So, did it get thicker? Yes. So if I keep on putting one shell after another, eventually I'm going to get a solid. Agreed? Yes. Okay. Going back to this. I rotated it to get this hollow shell. But the surface right here is it thick or thin? Pretty thick, right? If I do the same thing with some thickness to it, would the logic change of me filling stuff? No. As I put one hollow shell inside another, I keep on putting stuff in, I'm going to end up getting a solid. The only difference is instead of thin pieces, I'm going to use slightly thicker pieces, correct? Infinitely speaking, if you use an integral, this is this is not as thin as one would expect. It's thinner than this. But if you want to do a Riemann sum, you need thicker slices that you rotate to form a hollow shell and start stacking up or putting it aside to end up getting a solid. First thing. So that simply is the method of cylindrical shell. So what are the things do we need? One, I need the thickness. Agreed. We spoke about the thickness. It is very thin here. I can make it thicker. Two, when I do this, what is going to help us form a volume? In order to get volume, we need something. We've been doing it the entire time, Caleb. The area. Okay, last time it was enclosed area between two curves. Yes? What kind of area is here? Do you see an area?
A rectangle.
Rectangle? Well, it's,
If you cut the side.
you mean here?
Yeah.
Go piece by piece inside?
Well, it's because I'm the area because it's hollow, so it's just the outside and then with the delta.
Oh, you're just saying the outside area?
Yeah.
Okay, close. Perhaps you're just not using the right term.
I was just gonna say surface area.
Surface area, right? So since each shell is going inside another, the area that we're looking at is the surface area. Good. And you've got a thickness, you've got surface area, put infinitely many shells together, you end up getting a solid. Agreed? Hence the name Method of Cylindrical Shells. Okay, let's start with a cylinder. Suppose you have a cylinder with height h. Radius r. What is its surface area? Michael 1.
I was gonna say pi r squared h, but I don't think so.
Pi r squared h, that's the volume.
Two pi RH.
Very good, isn't it? 2 pi r h. But, well, another way of looking at this, the 2 pi r part, I can split it off as one term, h another term. I'm getting surface area. Where is that 2 pi r coming from?
Is half the inside of the circle, right? So 2 would make the whole, and then pi is the.
You are going the right direction, but it has a simpler term in geometry. No. Well, 2r is the diameter. 2 pi r, right?
So the area of the circle.
Area is pi r squared. George,
The circumference.
the circumference of the circle, right? So you have circumference, you've got height, you put them together to get the surface area. Yes? Okay. Have we found the volume yet? No. That's where the integral part comes into play. Well, with my explanation here, I needed thickness, correct? How did we define thickness thus far? The disc method, washer method. What gave us thickness? I said we've got to draw this each and every time, each and every time. That's important. Line, strip. You've got to draw that strip. That strip is going to define the thickness. So, volume, circumference, height, multiplied by thickness. Now that is either going to be dx or dy, depending on the axis of revolution. Good. We have to find the radius, we have to find the height, dx or dy, we have the volume. All we have to do is integrate. It is something we've got to be careful, which is the axis of revolution. That is going to determine what integral we are going to set up, just like the previous case. Last two cases with the disk method, we had to find the radius. With the washing method, we had to find the inside radius, outside radius. Here, we have to find our radius, h, height, and then thickness, but we should start with the thickness part first, because that is going to tell us what integral to set up, just like every single case prior to this. Good? Okay, well. Let's start simple. Some curve, let's just say y equals x squared. And I want to get the area enclosed between the y-axis and the curve. Seeing this way. What method should you use? I mean, what comes to your mind? Disk method would be the easiest that I would go for. Well, it's just a simplified version of washer method, right? One of the curves is just the axis. So this washer, whatever. That's the easier approach here. And we are able to do it easily because we could have the equation of the curve, y equals x squared. Yes. Since we are spinning it about the y-axis, what would the setup be? The integral. Where do we start first? Where do we start first? 0.
Everywhere.
It's not so high enough, is
Well,
it?
it's never alert.
That's why I put do not disturb on my phone. Not that I'm intending. Not that I'm intending. I'm just saying. Did not come across. Moving on. So this method, sure. Sarah, was it you who said 0?
Well, I thought you were meant from 0 to something.
Yeah, so sure, the bounds matter, right? But even before we get to the bounds, what should we do?
Turn to wire x, take the x to y.
The 5-letter word starts with S, ends with B.
Sketch.
Stretch.
Oh,
Stretch, it doesn't have 5 letters, Alex.
Sketch.
It still doesn't have 5 letters. Sketch what?
The strip.
Very good, the strip. So is the strip going to be horizontal or vertical? Horizontal, okay. There is my strip. Now I know, as Sarah pointed out, this strip is going to move back and forth about the y-axis. So dy, 0, 1, pi. All I have to do is find the radius. Yes, no, maybe? Well, Since this is dy, the integral has to be in terms of y. Do you agree? So if I pick an arbitrary x here, that simply is the radius. As this x moves back and forth, the radius is going to change. So x squared will be my radius. But here is a problem. I can't integrate directly. Why? Integral with respect to y, not x. I can't treat x as a constant, so what did we do? Michael?
Find x in terms of what?
We just find x in terms of y. Easy problem, right? Y equals x squared. I have it right there. So pi integral 0 to 1 y dy pi over 2. End of story. Good day. Y squared over 2, plug in the limits, integral. Right? X squared is simply y. Right? So I rewrote x squared as y. Integral y squared over 2. Plug in up low limits. 1 over 2 times pi over 2. Easy. Good. Here is the challenge. Saying here, I am going to do this. Good. So previous case, we had x squared right here. We had to rewrite it in terms of y because the strip is horizontal, integrating between 0 and 1. Everything's great. I was able to do it easily. Rewrote x in terms of y, like Michael number 2 suggested. Easy. Same problem. I know the radius is x. The first step doesn't change except for the bounds. So I have 0 to 2 this time. dy. The radius is x, and I have x squared. I want you to rewrite x in terms of y. Otherwise, we cannot integrate. Do you agree? We want the integral in terms of y. Here it was easy. Y, x squared was just equal to y. Things worked out. How do you solve for x and rewrite it in terms of y? Side note. Well, let's start simple. That was a piece of cake, yes or no? Previous case. Is that a problem if I ask you to solve for x? Easy. Is that a problem if I ask you to solve for x? Caitlin says yes. Why? Yes, why? X. Oh. Okay, Raphael.
You could factor out an x.
Okay, Raphael says let's factor out next. Why not?
Oh, if you solve for actually, I just realized you still have to
You
have
take
y
the
in there.
mark.
You still have to have y in there, but you would have an idea.
You just can't describe it without using x. No matter how hard you try, you cannot isolate y and x on either side of the equation. Painful, can't do it. It's not even painful, you just cannot do it. So this is a case where you cannot use this method. The only way that you've got left is cylindrical shells. Good? So you've got to pick and choose your battles. Sometimes This method would easily give you the answer. So don't spend time using cylindrical shells, but there are cases where you've got no option but to use cylindrical shells. Good. So I'm going to take this case, y equals x squared plus x. Do we understand this logic? Circumference, height, thickness. I just want to set up the integral. Rotating about y-axis. We want a good shell. My example, I took one, put one inside, and then put the third one vertically, one inside the other. Yes. And I started stacking things vertically. So the shells went vertically. Same thing must happen here. One, two is my point. The curve that we are talking, referring to is x squared plus x. Shaded area. I need to stack up cylinders, shells, one inside another, and fill it up. If you wanted to draw, not that way. Okay. Cylinder to stack up. That's the first bit. Maybe I'll put one more in the middle, right here. In a different color. Good. So you are starting to put one cylinder of shell inside the other. You're trying to make it thick, thicker and thicker, fill it up so that you get a solid. So the 2 pi part is easy. That's what we want. If we integrate 2 pi, easy. We have R, H, and the thickness. We need to figure that out. So 2 pi okay. Where is the strength? Isn't it? Is it horizontal? Is it vertical?
Vertical.
Very good. I asked you because you had this picture when you explained. So why vertical?
Because we're going vertically, we're going around the x-axis, so the shells are gonna be standing up, if that makes sense. So the thickness that they're gonna have is be about the x-axis. So they have to be vertical, have a change in X.
So if the thickness is this way, and if I spin it about the y-axis, I will have a surface, correct? Agreed. The thickness has to be vertical, so when I spin, I form a surface. Yes or no? If you had thickness this way, but you are spinning about the y-axis, would you have a surface, or, I mean, would you have a cylindrical surface or just a flat surface? A flat surface, agreed. Let's say I have some thickness here and I'm going to spin it around. I'm just going to have a flat surface, that's it. I don't want that, I want the surface area of a cylinder. So, strip, spin it, I have surface area. So, the strip in this case is in terms of x, so I'm going to start with the thickness of x. If that is dx, then that indicates that radius and height, both of them must be in terms of what variable? X or y? Where is the sound coming from? Who said x? Michael, was that you? Michael number 2 said x. So dx simply would mean the radius has to be in terms of x. The height has to be in terms of x. Well, I have my cylinder and I've got the height also shown here. Would you consider that to be height of the cylinder? Yes. And same over here. Yes, for the second shell. Same over there for the third shell. Good. Now that height is changing as you move. It is changing with respect to which curve? What is defining the height? I'll give you a hint. Okay, that height, 5 over 16, 3 over 4, 21 over 16. So how am I getting these numbers? This is at 1 over 4, the next one is at 1/2, the next one is 3 over 4, I think my math is right. How am I getting those numbers? Caleb?
Plugging them into y equals x
I'm
squared
plugging them where?
into the formula.
In this function, correct? I plug in 1 over 4, I get that height, 5 over 16. I plug in 1/2, 1/4 plus 1/2, 3/4, I get that height. I plug in 3 over 4, 9 over 16 plus 3 over 4, which is 21 over 16, I get that. I go over here, I plug in 1, what will I get? 2, good. So the height is actually defined by what? The starts with F, a lot of fun.
Function.
The function. So height is f of x. All we have left here is x. Oh, sorry, not x, the radius. As I got these heights, I moved the shell. Do you agree? So first it was 1/4, then 1/2, then 3/4. So I picked 1/4. I got a height of 5/16. Then 1/2. Lastly 3/4. Finally, 1. With me. So radius of 1/4, radius of 1/2, radius of 3/4, radius of 1. So as the height changes with respect to the function, what is the radius changing with respect to? Caleb?
It's X.
X. X value, X value, X value, X value. Yes. F of X, F of X, F of X, F of X. So the height is defined by F of X. Radius is defined by X. X. The bounds in this case, what are the bounds? Bounds have to move for X or Y. Or integral is in terms of X. Yes? So the bounds have to be 0 to 1. You should already notice something significant or a significant difference between this problem and this washer method. Hence, look at this integral right there. Look at the basic one that we started before I gave up and said we can't use this method. There is a difference between this and that. Both cases, I am revolving about the y-axis. But what is the difference? Okay,
Is it that you have X and Y? Like, is that respectively Y?
I can't hear you.
Don't you have like X and Y, because F of X is technically Y? Or
Okay. Something else. I'll give you a hint. For some reason, you don't like the strip. It has something to do with the strip.
Or in dx instead of dy.
This has dx, that has dy. Revolve about the x-axis, revolve about the y-axis, or any line parallel to the y-axis, an integral is in terms of y, correct? But method of cylindrical shells is the opposite. If you spin it about the y-axis or a line parallel to the y-axis, the integral will be in terms of x. If you spin it about the x-axis or any line parallel to the x-axis, the integral will be in terms of dy. Nothing else will change. You will have y, f of y, dy. Good? See the difference between the two? Again, it is a battle that you've got to pick and choose. Some students have known some students who prefer cylindrical shells, very comfortable with that particular method. Some hate it, and whenever possible, they simply go for disc or washer. So it is a matter of choice, whether you pick cylindrical shells or disc washer method. But there are cases like the one I illustrated here. you've got no other choice but to use method of cylindrical shells. Good? Okay,